Hi, everybody. My name is Matt DeVerna. I'm happy to welcome you all to the Observatory on Social Media's Awesome Speakers event. Before we get started and pass things off to our awesome speaker for the day, I'll give a quick introduction to the Observatory and the series, as I usually do. It's just a couple minutes, and then we'll get into the good stuff. So for those of you who are learning about the Observatory on social media, or OSoMe as we refer to it with the acronym, the OSoMe is a joint project of the Luddy School of Informatics, Computing, and Engineering, and the Media School at Indiana University. OSoMe is an interdisciplinary research group that is interested in all things at the intersection of media and technology, with a focus on social media, as the name implies. We conduct rigorous academic research, build analytical tools and software for both scientists and journalists, and work to educate the next generation of computationally skilled media professionals. So if you want to learn a little bit more about the observatory, you can check out the link at the bottom of the slide there, osome.iu.edu. And as part of the observatory's interdisciplinary mission, we've organized the Awesome Speakers virtual event. So this event consists of a series of talks from some of the brightest researchers and scholars who are working to rigorously understand how social media, the internet, and technology impact the world. So if you're interested in today's talk, we have some more lined up for the rest of the semester. We've also had some that we did last semester and earlier this semester. Most of those talks are recorded and available for you to watch if you happen to miss those on a YouTube page. And you can find out all this information by visiting the events page on our website, which you can see here. And with that, it's really my pleasure to introduce Dr. David Rand. David is the Erwin H. Snell Professor and a professor of management science and brain and cognitive sciences at MIT. He's an affiliate of the MIT Institute for Data Systems and Society and the director of the Human Cooperation Laboratory and the Applied Cooperation Team. Bridging the fields of cognitive science, behavioral economics, and social psychology, David's research combines behavioral experiments run online and in the field with mathematical and computational models to understand people's attitudes, beliefs, and choices. Taking a cognitive science perspective, his work focuses on illuminating why people believe and share misinformation and fake news, understanding political psychology and polarization, and promoting human cooperation. David's received a number of prestigious awards, including Wired Magazine's Smart List in 2012 of 50 people who will change the world. He was selected as Fact-Checking Researcher of the Year in 2017 by Poynter Institute's International Fact-Checking Network, and received an Early Career Impact Award in 2020 from the Society of Judgment and Decision Making. He's also co-authored some papers that have been awarded Best Paper of the Year in experimental economics, social cognition, and political methodology. So needless to say, I'm really excited to pass things off to David. But before we start, I'll just remind everybody of the structure that we usually take, which is that David will present for about 40 to 45 minutes, and then we'll do questions and discussion at the end for about 15 minutes. So you can leave questions in the chat if you prefer, but we'd really encourage you to sort of save those questions for later so that we can have a nice discussion. And now I'll ask that we welcome David. And David, thank you so much for being here today. I'll stop sharing and let you take over.
Great. Thanks so much for the invitation. Hopefully everybody can see my screen.
Yep, look good.
Great, thanks. And then I'll also drop links in the chat as I go to things that are relevant. Just get that set up. Yeah, great. Okay, so yeah, thanks very much for the invitation. I'm going to talk today primarily about a new paper that posted fairly recently, which is this paper, Reducing Misinformation, Sharing on Social Media Using Digital Ads, which was co-authored with all of these lovely people. Misinformation, is a topic that doesn't need much introduction. Here in particular, I think it doesn't need that much introduction, but obviously, like, falsehoods have been around forever, but there's a particular flavor of like false or misleading claim that has gotten attention in the last 7 or 8 years, starting with the 2016 presidential election in the US and Brexit vote in the UK, where there were fabricated claims posted online, spreading widely. And among the many different questions that have gotten a lot of attention in this space, the thing that I have been most interested in recently is the question of what can we do from a sort of practical perspective to actually reduce the spread of misinformation online. And the current approaches, and like, again, I think it's important to say that social media is not the only place that misinformation spreads. I think honestly, it's probably not even the place where misinformation spreads the most. I think there's a lot of mainstream, well, maybe one in particular mainstream news outlet that does a lot of spreading of misinformation to large audiences. But I think that social media is a really important place to think about misinformation because there's the opportunity for intervention. Because the social media platform that's distributing the information is not the same as the entity that's creating the misinformation. And therefore, there is some potential for intervention. And, indeed, a lot of the tech companies and social media companies have been doing a lot to try to reduce the spread of misinformation. And the sort of current standard of care largely involves identifying posts that are likely to be misinformation, and then either demoting them, so using the algorithmic ranking to basically say this is not good content, and push it down in the feed so people are less likely to see it, which more or less mechanically works in the sense that it reduces exposure. And putting warning labels on content that's judged to be inaccurate, typically by professional fact checkers. And there's also a lot of evidence that professional fact checker warnings labels work. We had a recent review paper led by the amazing PhD student Cameron Martell. I'll drop a link to this in the thread, where we reviewed a lot of literature on warning labels, and it seems like they work. They usually are in reducing belief and sharing tensions by 25 to 50%. And there's no evidence really of these kind of ideological backfires. So like even when you're correcting things that people want to believe, they believe it less and they share it less. So like, in general, this approach is great. And if it was possible to put a label on everything that was inaccurate, I think that would have a really huge effect. But the problem with this approach is in terms of scalability. There's just way too much content posted every day, so that like almost a tiny fraction of all content gets checked, and even the stuff that does get checked, it's slow, and a lot of the time it's already done spreading essentially by the time it gets checked. And so these content specific approaches of downranking and labeling have this fundamental issue of it works well once you catch the stuff, but you need to be able to catch it. You're always kind of playing catch up. And so in addition to these kind of approaches, I think it's really important to have what we call content neutral interventions, which are interventions that are not content specific. You don't have to know specifically which pieces of content are problematic and which ones aren't ahead of time, but you can sort of get out ahead of the misinformation and do something to sort of reduce its spread before you know what exactly it's going to be. And the particular approach that I'm going to focus on today is rooted in the observation that the social media context is a very distracting context. You're scrolling quickly. There's like, the news is mixed in with baby pictures and cat videos and funny memes and all this stuff where accuracy isn't even a relevant concept. And also you're getting these direct social signals about like who shared it, who liked it, whatever. You're not getting direct signals about accuracy. And so all of this stuff means that even if you don't want to share inaccurate content and could be reasonably good at telling what's true or false if you thought about it, people will simply forget to think about whether things are accurate or not before they share it. So that's the kind of premise that this is based on. And if that's true, then simply getting people to consider the concept of accuracy, not without giving them more information, without telling them what's true or false, without telling them they should care about what's true, whatever, just making the concept of accuracy salient should make people more discerning in what they share. And in past work, we've done a lot of survey experiments investigating this idea, essentially the idea that prompting people to think about accuracy will improve the quality of what they share. For example, we've done it by, at the beginning of the study, we say, hey, help us pre-test an item for another study. How accurate do you think this one random headline is? Then they go on to the main study where they see a bunch of posts and we say, would you share this or not? but by asking about accuracy at one item at the beginning, it's primed the concept of accuracy. Or we might give them and I should say, I'll put in the thread is this paper was the paper where we sort of like proposed this idea that there's this disconnect between accuracy and sharing, and showed that, you know, some of these kinds of prompts can get people to increase the quality of what they share. You know, we also use these kind of minimal digital literacy tips where I don't think the tips really teach anyone anything important that they didn't know, and they may not even really read the tips, but just like reading this top bar makes, oh, think carefully about the news. Yeah, okay, I guess I should, you know, sort of activates the concept of accuracy. You can also ask people how much they care, you know, about sharing inaccurate news. Like, you know, how important is it to only share accurate news? Almost everyone will say very important or extremely important, and then they'll go on to have that activated for them. Or you can also tell people that other people think it's very important. We find this works. Sometimes it works, sometimes it doesn't. It's sort of less consistent than the other ones, but like overall, there are all these different ways of prompting people to think about accuracy. And, you know, as I said, for the last few years, we've been running a lot of these experiments. And we have this like personal meta-analysis, or like internal meta-analysis, where I'll just put that in the chat, where we looked at 20 different experiments that we ran over a period of a few years, more than 26,000 Americans. And we found that on average, prompting people to think about accuracy reduced their sharing intentions for false claims by about 10%, and had no effect on their sharing of true claims. We found that this worked for headlines that were political and aligned with your party, political and not aligned with your party, about COVID. It worked for conservatives and liberals. It worked for a wide variety of different headlines and different ways of prompting people to think about accuracy. And then we also had a big cross-cultural study that we ran on 16 different countries, in 16 different countries on all 6 inhabited continents, using COVID-related news. And we found a similar result, that prompting people to think about accuracy, like reduced their sharing intentions for false claims by about 9.4% and had no effect on true claims. So this is the kind of like coming into the current project, we're like, all right, there's lots of evidence from survey experiments that getting people to think about accuracy can reduce their sharing of inaccurate content to some extent. Obviously, it's not a silver bullet. It's not the, you know, the one solution that solves everything, but it looks like, you know, it's doing something useful. And you know, importantly, it's content neutral. We don't need to know anything about the content beforehand for it to work. And so what we're asking in this current project is, okay, if this was really going to be done, how can we test this at scale? And the answer that we're going to investigate is using ads. So the way we kind of got this idea actually is that during the 2020 election, an advocacy group that we had been working with, like, thought the survey experiments we did were compelling, and they hired a design firm to make a bunch of these kind of ads like this based on our research. And then they ran them on disinformation websites, and they said they got a ton of traction, and they really thought that it made a difference. But whatever they did was not a real experiment. It was, you know, it was not easy to make any kind of causal, you know, draw any causal inferences from this that the ads actually did anything. So we wanted to know, let's try and really do this in a careful, rigorous way and see, does showing people ads prompting them to think about accuracy improve the quality of the information that they share? And the reason that, you know, there's some reason to think that the answer might be yes, is there's a large literature on the effect of social media ads. And like, maybe not surprisingly, given that the whole business model of platforms like Facebook is based on selling ads, like social media ads have a meaningful effect on outcomes. So for example, this meta-analysis of more than 600 ad experiments on Facebook, where they're, you know, trying to sell widgets or whatever, found that the median ad campaign led to a 5% increase in purchase behavior and other related sort of bottom of the funnel, as they say in marketing, outcomes. And in the context of public health stuff, this paper by Susan Athey and Nils Warnerfelt and colleagues in PNAS in 2022 looked at you know, more than 800 COVID-19 vaccine PSA ad campaigns on Facebook and Instagram, and they found a significant effect, an improvement of about 1% in people's attitudes towards the COVID vaccine as a result of the treatment. even though that was like a pretty calcified attitude. Um, and then this paper by the acronym team looked at, in millions of dollars, 8-month long political advertising pro-Biden ad campaign with the holdout group during the 2020 US election. And they found that the ad campaign led to like a 0.3 percentage point decrease in turnout for likely Trump voters and a 0.4 percentage point increase in turnout for likely Biden voters. So the idea is social media ads can have an effect on behavior, and like lots of different kinds of behaviors. And this is this like sort of magnitude of effect you should expect if the ad campaign, if things are going well, this is the kind of thing that you might expect. So we want to know, can we find similar effects on what people share from ads that prompt them to think about accuracy? And what I'm going to do in this talk and what we do in the paper is we talk about two different experiments, one run on Facebook and one run on Twitter. And they're complementary in that both of the experiments have the same goal, which is they use an ad campaign to show users ads about accuracy and see how it affects their subsequent misinformation sharing. But like in all other ways, they are different in their details. So they kind of provide convergent evidence here. Starting with the Facebook experiment, this is an experiment that was conducted by a team of researchers at Meta, plus Nils Warnerfeld, who's a professor at Kellogg, and me as the sort of like, academic advisor. And in the experiment, they selected 33 million Facebook users, which was mostly a general population sample, and they also upsampled 350,000 users that had shared misinformation links a couple of months before the experiment to try and increase the amount of misinformation sharing in the data set. And then users were randomly assigned to either the control or the treatment. And the people in the treatment were shown an average of 3 ads over the course of 3 weeks, where normally they replaced whatever the ad they would have seen for whatever kind of widget. They replaced it with an accuracy prompt ad that were meta branded, and they were ads that from this set, where says like 2 tips for thinking critically before sharing an article, and then there's some like fine print tips. My guess is nobody actually read any of the tips, but they just the point is you read this thing on the top, you say, oh, think critically, yeah, I should do that. Or like a little video that says check for accuracy, or this question about how important do you think it is to be accurate. Again, I don't think people carefully read this stuff, but you see, oh, accurate, oh yeah, I should think about accurate, like whatever. So they get essentially one of these a week for 3 weeks, and then the people in the control just get their regular ads, and so that we can compare the amount of misinformation shared by the people in the control versus the treatment. And to classify, a lot of the key question in these kinds of studies is how do you decide what's misinformation and what's not misinformation? And what we do in this experiment is we take advantage of the fact that Facebook has developed a range of signals for what content may be misinformation. They partner with third-party fact checkers. So if third-party fact checkers said that something was false or misleading, we're going to consider that misinformation. They also have a representative group of Facebook users through their community review product that are evaluating content. If community review flags it as, as inaccurate, then we're going to call it misinformation. And then they also have a classification algorithm that's trained on, this and all their kinds of signals to try to predict at scale what content is likely to be misinformation. So, we're going to say if any of these 3 things flag it, then we're going to say it's misinformation. Obviously, this is an estimate. It's not a perfect classification, but it's the best that we got. And, it's sort of better than a lot of past work in that it's not limited only to URLs, and it's not, past work usually says, and this is also what we do in the Twitter experiment, says, is it from a low quality URL or not? But so it's not relying on URLs. It's including lots of content that doesn't have any URLs in it. And it's also much more precise than just like, is it a good domain or a bad domain? Because it's tailored to the actual content of the post. And then, in line with other kinds of estimates around the prevalence of misinformation sharing, what we found was that like in the week before the experiment, 93.5% of the users didn't share any misinformation. And among the people who did share any misinformation, 60% of them only shared one post. So this is mostly like a 0-1 outcome. And so for that reason, in the Facebook experiments, as our outcome, we use just like this binary outcome. Did the user share any misinformation or not, during whatever period we're talking. So, okay, with that as the background, again, we're going to want to know the people in the treatment that got shown the accuracy prompt ads, were they less likely to share any misinformation than the people in the control who saw the regular ads? And I'm going to start by examining the effect within the browsing session that the ad was delivered. And so to do this, we're just going to look at posts between when they got the ad and then the 60 minutes of following. We find that more than 80% of users are no longer active after 60 minutes. So that captures the browsing session for most people. And the effect for this group is a 1.8% reduction in the probability of being a misinformation share. So, okay, that's doing something. But of course, a large fraction, that is the large majority of those people, were never going to share any misinformation anyways, if only something like, 5 or 6% of people were sharing misinformation the week before, then in the browsing session, probably substantially less than that were actually going to share. So, to get a better effect, a better sense of the effect of the treatment on the relevant subgroup, we're going to say, what happens if we only look at the people who shared at least one piece of misinfo in the previous week? Those people are much, much more likely to share misinformation during the target session. And there you get an effect that's 50% bigger or whatever. It's like a 2.6% decrease in the probability of being a misinformation share among during that browsing session, and there's totally no effect at all among the people who didn't share anything pre-treatment. And these two numbers are different from each other. So this is evidence that there is a meaningful effect, particularly among people who are sort of likely misinformation shares. Now, of course, it's almost all of the sharing here, and just on social media in general, is resharing rather than primary posts. And it's not possible to reshare misinformation if you didn't see any. And so in our experiment, we don't have data on who was exposed to misinformation or not. But we can back out and we can say, like, if during this treatment session, like that, during the session that we're looking at, the browsing session, like what fraction of users were exposed to at least one piece of misinformation. And so you can say, like, what was the treatment effect among the people who had the chance to share anything as based on what fraction of people actually saw something. So if it was 100%, then it's the numbers I told you before, where it's like a 1.8% decrease for all users and a 2.6% decrease for people who shared something pre-treatment. But what you see is that, like, under what seem like reasonable assumptions of something like maybe 10 to 20% of users exposed to a piece of misinformation during the browsing session, that implies treatment's effect on exposed users that are actually like quite large. Okay, so this is all to say within the browsing session on Facebook users, seems like the prompt, showing them the accuracy prompt ads are doing something relevant. We use these 3 different ways of prompting them. We didn't find any significant difference across approaches, and if anything, the tips worked a little bit less well than the things that were just more like, hey, think about accuracy. And this is consistent with survey experiment evidence, where we tried a whole bunch of different ways of prompting people to think about accuracy, and they all pretty much work the same way. We also don't find any significant moderation by users' gender, their age. We use a dummy for over 65 or not, because past work found that people over 65 are much more likely to share misinformation than younger people, and whether they have a college degree or not. And to the extent that there is some moderation by age, it's in the direction of like it working better for older users. So, again, like not much evidence of individual heterogeneity, which is also consistent with what we find in the big meta-analysis of survey experiments. And also importantly, there's no effect on their sharing of non-misinformation content. It's not that the ad makes them just like not want to do anything. If you do a quasi-Poisson regression predicting the total number of shares of like non-misinformation shares, there's no significant effect on that, whereas there is a significant effect on the number of misinformation shared, and these two numbers are different from each other. So there's a significant interaction. And so this says that it has a significantly bigger effect on misinformation posts than on regular posts, which again is like consistent with the theory and also important from an applied perspective. So, okay, within the browsing session, it looks like it's, it's doing something. What about if we look over the full 3-week campaign? So over the full 3-week campaign, there's no significant effect of the treatment. But, this is maybe not surprising, given that they were only being prompted once per week. And, if the idea of this whole intervention is, it's not teaching them, it's not, providing them with any sort of sustaining knowledge, it's just kind of like trying to shift their attention around. Attention is very fickle. And so it's not surprising that if I prompt you to think about accuracy, this time, when you then go on and you live your life and all these other things happen, and the next time you log on to Facebook, it's unlikely that you're still going to be thinking about accuracy from when we prompted you the last time. And so, what we wanted to know is what happens if you prompt it more regularly. And because the fact that we see an effect within the session suggests that, like, if we were to prompt people more regularly, then we might see a sustained effect. Although on the other hand, it might not work because people might start ignoring it or something like that. So we wanted to know what happens if you consistently or sort of regularly prompt people. And so this brings us to the Twitter experiment. And so the Twitter experiment was conducted by our research group at MIT, led by the amazing postdoc House Lin. We ran 3 experiments lasting 8 to 22 days, in which we sampled active users who had recently shared misinformation. So here by misinformation, I mean links to low quality news sites. I think I'll talk more about that in a minute. But the idea is here we say, here are users who in the week before we start our experiment, they shared at least one link to a low quality news site. So they're kind of analogous to the people on Facebook that we were trying to subset on. So these are the sort of like group that you might be concerned about, the ones you would want to treat. So it's all the users in the Twitter experiments are those kind of people. And then we basically told the Twitter ads, have an unlimited budget and show them as many ads as possible, for the duration of the campaign. And that translated into the average user seeing 3 prompts a day, every day for, 8 to 22 days. And we didn't want people to just start, we wanted to minimize the chance that people just started ignoring the ads. So instead of just showing them the same ad again and again, we developed a set of 50 different accuracy prompt creatives that all sort of prompt accuracy in different ways. And the ad campaign just kind of sampled from that big set of creatives in order to keep it fresh and interesting. And unlike the Meta experiment, these prompts were not were not Twitter branded. They'd had, our account was called Think Accuracy. They were Think Accuracy branded, and some ad like this. And then to the extent that there's some brand, it's University of Regina, which is where Gord Pennycook, one of the collaborators on this, was located at the time we ran the experiments. So there's things like this: is it accurate? There's this quiz: hey, do you think this is accurate or not? And then some of the creatives may be more attention grabbing than others. For example, this picture of a butt certainly grabs people's attention on the internets. And then here's another example of just like, again, I don't think the tips are really doing much for people, but the point is it's making them think about accuracy. And so, okay, the people in the treatment are getting these accuracy prompt creatives all the time while they're on platform. The people in the control are just getting regular ads. And then our key outcome is going to be how many retweets did the person do that were misinformation. And here we're going to take the sort of standard approach of classifying something as a misinformation tweet if it contains a URL to a low quality domain. And by low quality, we're going to mean below a score below 70 out of 100, using the rating set from this another paper of House's published in PNAS Nexus last year, where he took 6 different sets of expert ratings and he aggregated them in some sort of sophisticated way to make a big master list of like 11,000 domains. We got like ratings, expert ratings for 11,000 domains. And this paper actually was another like really sort of useful outcome of the whole project, in that like that paper just happened because we were like, oh, we're going to need to score all this somehow. And House is like, oh, cool, let me come up with this like approach for doing it. And then it was like, oh, great, actually, this approach in and of itself is super useful. So for people doing, social media research where you want to classify domains, in the chat, here's a link to that paper. Okay, so we're going to choose 70 as a threshold because based on examination, that seemed reasonable to us. But in the paper, we show that you can set this threshold anywhere between 40 and 80, and it doesn't really qualitatively change the results much. Again, this is doing the standard domain level thing rather than the post level evaluation that we were able to use in the Facebook experiment. And that is obviously a limitation because you would like to be able to know more specifically, is this post bad or not, rather than just using the domain as a proxy. But it's the best thing you can do when you've got huge numbers of tweets and no sophisticated classifier. So that was true in all of the Twitter experiments except one of the Twitter experiments. We selected users not just for sharing low quality news in general, but specifically because they were sharing hashtags related to a particular conspiracy theory event, conspiracy theory linked event. And so then we're going to use for them the number of those relevant hashtags that they share. And so that's really more like specific to the, to the conspiracy theory. Okay, so now what I'm going to show you is we're comparing the treatment to the control in a quasi-Poisson regression. So like the dummy for is it control or not. And then we also did blocked randomization to make sure that the treatment and control were like matched on many different characteristics. And so I think we have blocked dummies, and we control for the quality of content that they were sharing pre-treatment to increase the precision of the estimates. And what I'm going to show you here is this is the overall treatment effect across all the users in terms of percent change in the number of the number of these kind of low quality links they share. And each of the blue dots represents one of the experiments, and then the black dot with the confidence interval is the results of a meta-analysis sort of pooling the three individual experiments. And what you see is a 3.7% decrease in probability of sharing links to low quality sites. So that's good. It's in line with the other experiments, but it's a bit bigger, which is good because they're getting treated more. The way that the Twitter ads infrastructure works is, I guess, for privacy reasons, they don't show the ad to all the users that you say you want the ad to be shown to. They don't tell you which ones they do or don't. They're only like, yeah, so only 60% of the users that you said you wanted to show an ad to saw any ads. And so, ideally, we would know what's the treatment effect just among the people that actually received the treatment. But we can't. And so the main analysis just includes all the people that didn't see it, that didn't actually receive any treatment. But obviously, that's like an underestimate of the true effect. And so we can use an instrumental variables approach to estimate the average treatment effect on the treated. So like what we expect the treatment effect to be among the people who actually received the treatment, that is the people who saw at least one ad. And we'd estimate that among those users, it's about a 6.3% decrease in the amount of sharing of misinformation. And then similar to the Facebook experiment, there's no significant interaction between the treatment dummy and how much misinfo the person shared pre-treatment, whether the person, like how Democrat versus Republican the person was, estimated based on the accounts they follow, whether they follow any political accounts at all or not, how many followers they have. And this is important because if the treatment didn't work on people with lots of followers, then it wouldn't really have much impact. But it's, if anything, it works slightly better on people with more followers. And this is obviously like a log of followers because it's a skewed distribution. And also importantly, there was no interaction between the day of the campaign, which is to say there was no evidence that the treatment effect was getting smaller over subsequent days. So people weren't sort of like learning to ignore the treatment effect. And again, as in the Facebook experiment, there was no significant effect on the sharing of non-misinformation posts, and the effect on misinformation posts was significantly larger than non-misinformation posts. So this is, I think, quite optimistic, and it shows that the like single session results from the Facebook experiment can actually be achieved in the long run by just prompting more regularly. Now, the last thing is we also ran one experiment on Twitter in which the people that we targeted were not people who had recently shared misinformation, but instead they were people that hadn't shared any low-quality links in the 3 weeks prior to the experiment. And most of those users didn't tweet anything at all on most of the pre-treatment days. And sort of as in the Facebook experiment, there was no significant effect among these people, and the effect in this experiment was significantly different from the effect in the experiments where we were targeting active users. So this further emphasizes the importance of targeting this targeting this intervention at active misinformation sharers and not just, sort of doing it to everyone. So that's what we found. And now I want to sort of reflect on the magnitude of the effects that we found and how they line up with what you might have expected. So in our survey experiments, there's about a 9 to 10% decrease in the sharing intentions for false claims, for like really explicitly false claims. In the field experiments, there's about a 2.6 to 6.3% decrease in the sharing of misinformation claims more generally. And so I think that these field experiment effect sizes actually compare quite favorably to the survey experiments when you take into account the fact that in the field experiments, a lot of people didn't even receive the treatment. So even people who were shown the ad, many of them, I don't know about you, but I don't carefully study every ad that comes up in my social media feed. I try and scroll by them as quickly as I can without reading them. So probably a lot of the people in the treatment condition didn't even receive the treatment at all. Also, as I said, a lot of people are probably not exposed to misinformation and so don't have the opportunity to be treated. And we have this very imperfect measurement of the DV, whereas in the survey experiments, we know all these ones are false, all these ones are true. Here we're using proxies like the Facebook classifier or the quality of the domain to say what's accurate and inaccurate information. So I think that these field experiment effect sizes are pretty good compared to the survey experiments, and they're also in line with what typically you see in other kinds of social media ad experiments. It's also important to remember that the sort of practical implications of an intervention like this aren't just in terms of what is the effect on individual users, but really what you care about is the system level spread of content. And so these kinds of effects can be amplified by network effects. Because if I don't share something, none of my followers see it, so none of them share it, so none of their followers see it, so none of them share it, and so on. And also, it can be amplified through its impact on the algorithm, which is when people are not sharing content, then the algorithm is getting less input saying that it should show it to other people. So it will also likely reduce the sort of algorithmic presentation of that content too. And finally, I think one really important point here is that we used ads as the way to deliver this treatment. We didn't do it because we thought ads are like the best way to do this. As I said, ads, like everyone tries to ignore ads and hates them and so on. The reason that we used ads is because it offered an opportunity for us to do this experiment without needing any extra engineering. Like we weren't asking Facebook to build a new product that delivers accuracy prompts. We were able to leverage the existing ad infrastructure to deliver accuracy prompts. And similarly with Twitter, we were able to do the experiment without any participation from Twitter at all, just by using the existing ads infrastructure. But given that it seems like this does have a positive impact on the content that people are sharing, I think that this is something that tech companies could get much bigger effects from if they implemented it in a way that was harder to ignore. For example, like a banner across the top or like an interstitial you had to click through when you first logged in, things like that. And so I hope that future work on this will try and investigate like more effective ways to deliver the treatment that can result in larger treatment effect and also don't have the downside for platforms of lost revenue coming from displacing actual ads with accuracy prompts. So to conclude, I think we provide evidence that accuracy prompts can successfully reduce misinformation sharing in a real field experiment on platform. And this is a content neutral intervention, and it means it can help fill the gaps left by existing content specific interventions. And again, I'm not saying it's a silver bullet. It doesn't completely solve the whole misinformation problem, but it's like another tool to add to the like anti-misinformation toolkit. And we have this convergent evidence from both Facebook and Twitter. We implemented the same approach in different ways and found similar results. One of the key implications of what we found is that this isn't like a one-time treatment that then makes people good for the rest of their life, but because it's about attention, you need to regularly prompt people. And we don't directly show this in the experiment, but I have a strong suspicion that in order for this to be effective, you need to really make the prompts different. You can't just like keep prompting them in the same way, or then you get into the banner blindness kind of thing. Like, I don't know if you guys saw when Twitter implemented this thing where it says if you try to share a link that you haven't read, it says, hey, are you sure you haven't read this? Are you sure that you want to, like, maybe you want to read it before you share it? And the first time that happened to me, I was like, whoa, yeah, okay, maybe I shouldn't share it. And then after about the, after 5 or 10 times, I was just like, oh, whatever. Okay, when I want to share, I just have to double click instead of single click. So you need to mix it up. You can't just have it be a static thing or people will start it. Also, I guess another one of the key outcomes here was that it's not really going to be effective or efficient to target this, to deliver this treatment to all users. You're going to want it all the time. You're going to want to deliver it ideally to people that you have some reason to think are likely to be sharing misinformation, either because they are chronic misinformation sharers, or it could be because it's in a moment of crisis where you think there might be a deluge of misinformation on the platform or something like that. I guess one other key element of this is not only is it scalable and because it's content neutral, but it's also much less paternalistic in that it's not relying on a specific set of fact checkers or whoever deciding which things are true and which things are not true. It's just helping people make choices that actually are more aligned with what they would want to do if they were paying attention. And again, we used ads for simplicity, but I think there's much more effective ways to do this. So I wanted to say thanks to all of the co-authors. These are the folks at Meta. Nils is at Kellogg. House is a postdoc at MIT, where Adam Brinsky and Dean Eccles and I are. Gord's at Cornell, and Nate is a professor in Canada. And so I'll drop the links in the thread, but also we've got these QR codes for the working paper and the tweet thread. And also thanks to everybody that gives us money for research. And thank you guys all for listening, and I'm excited for Q&A. And so here's the like in the chat is the paper, and then threads on both Twitter and Blue Sky. And more generally, here's also a link to a Google Doc that has just like all of my group's research on misinformation, social media, fake news, polarization, whatever, for people that want more. So thanks a lot, and looking forward to questions.
Wonderful. Thank you, David. Really appreciate. We covered a lot there. I'm sure that folks have questions. It's super interesting. So we're going to open up for questions to the group. Please, raise your hand and we'll sort of knock them down. And then I have, of course, questions as well. But it looks like Oscar's jumped in. So Oscar, please go ahead and ask your question.
Hi, thank you very much for the great presentation. I like the way that you look at the problem of misinformation and like try to solve it, basically, not just to observe it, I guess. My question would be maybe a comment. I don't know. After LLMs came out, we started seeing more and more papers on how micro-targeting on social media users could be done in scale, and how they work better than running a campaign that is not really personalized. So there's a lot of papers that villainize LLMs by showing how they can be used to manipulate people by using their own data. But I was wondering, do you think personalized content that aim to like maybe personalize ads that contain some kind of prompt that that says people you should be careful about misinformation would work? Would that work? And if it does, how much do you think the effect size would be bigger?
Yeah, it's a good question. So my guess is it won't matter much because I think that like this is just about, at least in terms of the accuracy prompting part of it, all you need to do is just like prime the concept of accuracy. Like you don't need, it's not persuasion. That's the thing, is we're not like trying to say, I know you want to share this, but let me talk you out of it. Instead, it's like most people don't actually want to share misinformation. They're just not paying attention. And so all you need is to kind of prompt them to think about it. And they're like, yeah, okay, great. Also, just as a side note, my sense of the existing evidence is LLM driven persuasion, not at all clear to me that it helps even for persuasive messaging. Like I know there was a paper in PNAS Nexus that asked people, how persuasive do you think this message is? And the LLM has generated messages that people rated as more persuasive. But then there's another experiment that actually did persuasion, RCTs, on actual attitudes, and found that the LLM customized stuff wasn't any better than the non-customized stuff. And so my take on it is that where the LLMs are powerful is not in terms of here is some ad, like make it better for this person. But instead, where I think the LLMs have potential like really big power, both for good and for evil, is in terms of like in the more chatbot form of the ability to have back and forth conversations with someone about some particular topic and bring whatever evidence it wants or can make up to bear on that topic.
Great, thank you. Phil, go ahead.
Hi, Dave. Thanks. Great talk. And as always, I want to thank Matt and Caitlin for organizing this series.
Yeah.
And so you present a very compelling case here, and you have done it in a big body of lots of papers showing evidence that these accuracy prompts are effective, significantly effective, and the effects are, as you told us today, they vary depending on the settings and the experiment, the kind of exposure, the kind of experiment, and so on and so forth. But they are a few percentage points to several percentage points, maybe 10 or something like that. That's a lot, but it's not 100%, obviously. So I want to just ask your opinion, just zooming out, like even in the best of possible worlds in which all platforms deployed these kind of systems, maybe in ways, as you were describing, where that they are varied and that keep reminding the right people, and so on and so forth. So probably there would be a reduction, but it wouldn't be complete. So do you have any thoughts in general on like what else is there? Like, is it the case that we'll never be able to, get rid of this is a silly question the way I ask it. Of course, we'll never get rid of misinformation, but will we make a huge dent, or do we have to be content with small reductions? What's your general thinking like looking forward?
I guess that my take on it is like, it's a complicated problem. There's no silver bullet that's going to solve the whole thing. And what you want is like a combination of as many different approaches as you can get to like cover as much as you can. And so, like I said at the beginning, I think that demotion and labeling are super effective and are like a really important, like central piece of the approach. Because it's like a hammer, when you smash something with a hammer, boom. But like the problem is you have to know where to hit it. And so I think that the content neutral stuff like this helps fill the like large holes left by the content specific like approaches. But I think another really important aspect of this is trying to improve the the sorry the reach and speed of misinformation identification to help the content specific stuff work more effectively. And so part of that obviously is, developing better algorithms. And I think this is actually a place where LLMs potentially can be useful, although obviously like telling what's true or not is not necessarily their like biggest strength. But in this case, it doesn't necessarily have to be judging is it true or not, but judging like is it plausible or not. But I think another thing that we've done a bunch of work on and others have done work on is trying to use crowds to help evaluate or like help identify potentially misleading content in a much more scalable and faster way. And I'm quite optimistic about that as another important part of the the general approach. Like I think Birdwatch on or whatever community notes on Twitter is I think it is on balance quite good. I certainly, like everything else, it's not a silver bullet, and so I would certainly not have gotten rid of all of the regular content moderation and be like, "Hey, just community notes, we're good." But I think that it is like it's a valuable additional thing to have along with everything else to try to just expand the net of like how much stuff you're capturing. And actually, in the paper that I presented today, we have an analysis in the supplement where to get some evidence on the effectiveness of the current intervention approach, where you can look at like for all of the content that third-party fact checkers flag as inaccurate that people in our study shared. I think it was the week pre-treatment, I forget, or whatever. Some set of over some period of time, some set of users. You can look at how many shares was that content getting relative to when it was identified by Meta as misinformation. And what you see is, I'm sorry, I'm trying to do this reversal for you guys. This might be the wrong direction. Whatever. Essentially, it's like going along, people are sharing it, and then boom. It basically, as soon as it's identified as misinformation, sharing immediately goes to zero, pretty much. And so it was like, it is super effective when they decide, when they decide that something's bad, it's super effective. But the problem is, like, how do you get that to happen, like, at a large scale and quickly?
Thank you.
Anybody else, or I will jump in? Okay. So David, you talked a little bit about this concept of like content neutral interventions. Obviously, you introduced your accuracy prompts, which seem to be working pretty well. So I'm curious if there are others that you think are really promising or interested in exploring. As you move forward. Phil mentioned before, you've shown these are effective in a lot of different ways. So I'm curious if there's something kind of on the horizon that you're interested in exploring further. And then also a quick question about the stimuli. You had showed us a bunch, which seemed to, they kind of had sort of like media literacy tips that were sort of in there. And you had mentioned that, I'm not so sure people are really reading these, but this is obviously another area of a different kind of intervention in the literature. So how do you think about like the differentiating those two? I think I would tend to agree with you that people generally aren't reading these super thoroughly, but there is a bit of a overlap there in the kinds of things that people are being exposed to.
Yeah, totally. So I guess that maybe starting, well, I guess in both things. To me, broadly, the other class of interventions that I didn't talk about are these like literacy interventions of one kind or another. And the way that I think about those are, well, okay, actually, let me say, I feel like there's two different things. One is a content specific, but preemptive approach. This is what I think of as pre-bunking, which is like, oh, I know that there's going to be some false claim out there. Then I can say ahead of time before you're exposed to the false claim, hey, like watch out, here's the truth, and this people are going to be saying this false thing. And this kind of fact-based debunking, I think evidence suggests works really well. It still has a bit of the problem of you need to know ahead of time what the bad stuff is going to be, but at least you don't have to know ahead of time who's going to see it or whatever. So I think that fact-based pre-bunking is really good. But then there's what I think of this more general, this more general set of literacy interventions, which more or less all involve teaching people like things to watch out for. Sometimes it's done in the context of literacy tips. Sometimes it's done with these like technique-based inoculations where people try to teach people manipulative techniques to be on the alert for. You know, there's obviously whole media literacy training courses and so on. And my sense is that the evidence is really mixed about how well this works. And I think there are some things that seem like they work pretty well in terms of helping people, you know, making people less likely to believe false or deceptive claims. I think there's some that seem like they don't do anything, which is obviously not great. I think there are also some that make people disbelieve everything, which also is not great. And to me, that seems like the primary failure mode to watch out for in the media literacy context is, are you helping people actually tell true from false, or you're just making people be like, this is all seems like garbage. And I guess the one other thought on that is that I think that when done right, media literacy or literacy trainings can obviously make people better at telling true from false, and that is obviously like good and important, and is like first order important. But if you want to look at the effect on what people share, I think a lot of our work suggests that making people better at telling true from false is not necessarily going to have a huge impact on what they share, because people are forgetting to use the knowledge they have in the first place. So I see the accuracy prompt idea as synergistic with literacy, in that like the better you make people, okay, I guess I should say this, that I explicitly, like really in this talk I didn't say it, that like clearly one of the major limitations of accuracy prompts is they're only going to reduce the sharing of content that people think is inaccurate. So if there's something false and I believe it, prompting me to think about accuracy is certainly not going to help. And so there's this synergy where like it clearly makes the accuracy prompts more effective to make people's underlying, you know, accuracy judgments better. And also the accuracy prompts help improve, like make improving accuracy judgments translate into actual improvements in sharing.
Interesting. Thanks. Yeah, I appreciate the level of detail there. I see a question in the chat from Diana, who mentioned how is this research being received by the social media platforms? Any chance of campaigns being launched prior to the election to impact misinformation? Yeah, I was also curious about this and sort of like what the relationship was with working a little bit with Facebook to run the Facebook ad, and then also, I guess, wrestling with sort of Twitter ad system and what that was like.
So also I asked another question about the citation of the effectiveness of the labeling. So it's like in SI section 1.2 of the paper that I presented today, has that. Here, I'll drop the link again. And we don't know that it's necessarily labeling, because it's probably also the demotion. It's everything that's happening like together is super effective. In terms of the reception by the tech companies, clearly, so I think, you know, I get this question all the time, naturally. And I guess I should say, from a conflict of interest perspective, I don't personally get paid by any tech companies, but I do research support from, I have gotten research support from Meta and from Google. But so my take on it is like, you know, they say like, how interested are the tech companies in doing this? And I think the answer is the tech companies are not, you know, a homogeneous single agent. There are like thousands of people working in these companies, and the people that are working on misinformation related stuff are really serious about it and really want to do basically whatever they can to reduce the spread of misinformation. But the companies are really hierarchical, and so the extent that any of that stuff gets implemented depends on how well they can get buy-in further up the chain. And you know, so I think it remains to be seen how everything shakes out.
Fair enough. Fair enough. All right, we are at time here, so I'm going to ask that everybody please thank David one more time. And David, thank you again for your valuable time and really interesting presentation. And I'll have to say goodbye to everybody.
Thanks all. Take care. Thanks again for the invitation.